Good morning, everyone. Welcome to GitHub. We're so excited to have you here today. We've got some really exciting announcements that were coming today, and we've got a bunch of developers who've joined us here at GitHub headquarters in person. So first, I want to welcome all of you. Thank you for coming to our humble office here in what is today a little bit of a drizzly San Francisco. But we also have hundreds, or I think thousands at this point, of developers who are watching on the live stream around the world. So wherever you are, good morning, good afternoon, good evening. We're happy that you're here with us too. GitHub is a distributed team, and we're about 1,200 people now. And actually, about 3/4 of our team is distributed around the world. And so the fact that we've got a distributed audience for this event is extremely appropriate, and we're excited about it. This is the third event we've done in just a few months here at our headquarters where we're announcing new stuff. And so it's been a lot of fun for us to not wait for major conferences, but when we have something to say, bring folks together and say it. So we're glad you could join us for this. Now, over the course of 2019, we've made a number of really big changes at GitHub and some pretty major product features and announcements. And I wanted to kind of take a second and refresh our memories about that. I won't go through all of them because it would take forever, but 3 things that I'm particularly excited about. The first is just last month, on August 8th, we announced the new version of GitHub Actions, which now includes built-in CI/CD for all GitHub users directly in github.com, and will be available for GitHub Enterprise Server in the future as well. That's in beta now. The reception's been amazing. We're getting a ton of usage. It's actually incredible how many servers and VMs we have to spin up to accommodate everybody's load. Works on Linux, Mac, and Windows. And so it's been awesome. It'll be released to the public, generally available on November 13th. But if you go right now to the beta page and sign up, you'll get admitted instantly. So if you haven't tried it out, go give it a shot. We also announced a couple of months ago the GitHub package registry, where we've basically built a package registry into every single repo on GitHub. So whether it's a private repo with a private registry or a public repo with a public registry, we support 6 different package formats: NPM, NuGet, Maven, Ruby Gems, and Docker. And we'll be adding more in the future too. That'll also be generally available November 13th, which is just in like 60 days. And then finally, we're doing something pretty revolutionary and pretty amazing that I'm personally very excited about. Kind of a big experiment we're running with GitHub Sponsors, which we launched in May of this year. And GitHub Sponsors is a facility in GitHub that allows you to actually financially support the developers whose work you love and depend on. So if there are folks who are working on your dependencies that you want to make sure they're independent developers, they get the support they need, you can sponsor them there. We've had thousands of developers sign up for this. We have a bunch of folks now who use it to make rent every month. So that's pretty exciting. So lots more to come there, a lot more news. We've done hundreds of other announcements this year. So it's been an incredibly busy time, and today we'll be making some new ones. Before we get into those announcements, though, I wanted to kind of zoom out and put them in context. And I want to talk about this major shift in the way that software is built today that we're all grappling with. There's been huge changes over the last 20 years or so that I've been a developer. And that shift really is open source, right? Over the last 25 years, open source has evolved from being kind of a niche, almost pseudo-academic activity, where developers at universities or large institutions would write some code and share it with each other, similar to publishing a paper and build on each other's work, to being really at the foundation of all software, right? In fact, 99% of all software projects today use open source. It's actually hard to find a software project that doesn't use open source. All the language communities are open source, et cetera. And so, whereas in the 90s, when you were writing software, it might have been a fairly normal thing for you to start implementing your own kind of very low-level data structures. I remember writing hash tables and B trees and stuff like that myself. Now you can actually just, import huge libraries that communicate with satellites in space or do things like that. So the building blocks have gotten much higher level. We've also seen this huge trend towards these package registries and dependency management systems. And as a result of those, the transaction costs of using building blocks have gone way down. And the consequence of that is that our dependency graphs have exploded, right? It is now super common for us to see node applications, as an example, not to pick on anyone, but that will have thousands of explicit NPM modules that they are pulling in, and in their transitive dependency tree, huge numbers of components. So there's been enormous benefits to this, right? I mean, developers can actually focus on the code that makes their application unique instead of writing everything from scratch. And so, you get to operate at a higher level, you're more efficient, you get more done. And in a way, developers today can write less code. We're more like integrators. Grab a little code from, Ruby gems and maybe some Stack Overflow snippets, and then we'll write some also, but we don't have to do that as much. So it's a very interesting new world. Now, this new world has benefits, but it's also come with new challenges, right? And one of the most important new challenges is around security. Because it's great that you get to build on the work of thousands of strangers on the internet when you write new code, but it also means effectively that those thousands of strangers have commit access to your production code in a way. In fact, most of the code you're putting in production, you probably didn't write. It's sort of external to your team. And so you've got, the technical term for this is you have randos in your supply chain, basically. And that means if any one of your dependencies has a vulnerability, you have a vulnerability, right? And the fact is, this might not even be a dependency you knew you had. It might be a dependency of one of your dependencies. So this is the changing world, and kind of open source has succeeded and has had such a positive impact because it's so low friction, right? We don't have to ask permissions, sign a vendor agreement, form partnerships to collaborate on software. It's easy to forget that's how the world used to be. You had to sort of sign up and talk to folks before you could build on their software. But for the open source to succeed in the next 25 years, we've got to make some changes. And specifically, we have to change and improve our processes and our tools and our norms, our community norms and social norms, sort of upgrade the operating system of open source to adapt to the new threat landscape so that we can continue to build trust and security directly into the way open source works. So that is what we're setting out to do. And it's not a thing that GitHub can do alone, right? And this is a whole ecosystem and a whole community effort. It'll take lots of different folks coordinating together to do this. But GitHub is in this unique and position of tremendous responsibility in the ecosystem and tremendous opportunity to have a positive impact on this problem and the set of challenges. And so we've been working hard on this at GitHub over the last year or so and thinking hard about what does the ecosystem need to become more secure so that you at your companies or on your projects can do the right things and trust the code that you're using, and so that maintainers have the help they need to have great security practices. And so as we thought about this, we realized, well, actually, one of the challenges is there's not a single party who can make a difference here. In order to make open source software more secure, we have to coordinate the activities of at least 4 different distinct personas. We have to get security researchers, maintainers, the developers who consume open source code, and then in the case of companies that are large enough to have security teams, all of those parties to work together in a coordinated way. And one of the reasons that this challenge hasn't been addressed in the past is that the workflows and the tools and the processes you need to build span all these personas. And historically, people have looked at this problem through the lens of one persona. What can a developer do? What can a maintainer do? What can a security team do? And most products have tried to address a single persona. That's not what we're going to do at GitHub. What we're doing is we're taking this holistic view at what we're calling the open source security workflow to identify what needs to happen. So let me walk you through that. So the first step, the first persona is the security researcher, who is the individual, sometimes called hackers. They're like benign hackers, right? If you're familiar with HackerOne. And they're like geniuses, right? They look at code and they find the things the developer never intended that are possible in that code, whether it's a buffer overrun or remote code execution vulnerability. They do that through tremendous experience, insight, and pattern matching. They identify an issue, and then they have to disclose it to the vendor in the case of a proprietary application or to the open source maintainer. Those are great things, but there's 2 problems right now that those folks face. First, discovering and identifying these vulnerabilities is kind of an elite activity that only a small number of people can do, and it's a very manual process that doesn't operate at scale, right? And so there's wonderful teams out there like Project Zero at Google that do a great job of identifying these things, but it's a very manual activity. It scales with the number of geniuses you can employ, right? And the second issue is that in the case of open source projects, the best run projects that are corporate sponsored or have foundations, sort of the 1% of open source projects, they may have good ways for you to disclose vulnerabilities to them, but 99% of open source projects don't. You go to the GitHub repo, maybe you can file a public issue, suddenly the vulnerability you've disclosed is public to the whole world, it's a 0-day, that's not a great situation. Or maybe you clone the repo and find their email address in the Git log and then you email them. That's kind of the state of the art right now. So that's the first problem. Okay, once a maintainer learns about a vulnerability, they should verify it and fix it, ship a new release to their users, and then alert all their downstream users it's time to upgrade, right? Well, I think some of the challenges here that maintainers face is that open source communities are in public. And so if the developer, if the maintainer is trying to fix this issue, the tools they have to collaborate with their team are also public. So again, you have this 0-day problem where you can actually just watch maintainers struggle with active security bugs in public. And there's actually kind of a whole industry of people who scrape github.com to find these discussions and build databases out of it. So that's not a great situation. And then finally, for maintainers, for them, most of the time, if you're like the median open source maintainer, a security issue like this is a black swan event. You're not used to it. You don't know exactly what to do. No one trained you for this. How did you become a maintainer? Well, you just built a thing that you wanted, and somebody else liked it, and they started using it, and someone contributed, and now you're a maintainer. And now you have to know how to handle vulnerabilities and these kind of crazy events. And so how do you notify all your users and responsibly alert them to the fact that they need to upgrade? That process isn't on Rails. And then finally, as a developer who's consuming open source, if you are shipping code that you didn't write, strangers on the internet wrote, that contains vulnerabilities, and those vulnerabilities have been identified and fixed, well, you need to update, right? Like you need to actually update your dependencies so you stop shipping vulnerabilities. And then you should take steps yourself to prevent you or your team from incorporating more vulnerabilities into your code, either dependencies with known vulnerabilities, or like maybe repeating the same code patterns that led to that vulnerability in the first place, like that buffer overrun or whatever it was. The challenge here is that, in general, open source developers don't fix vulnerable dependencies quickly. In fact, the stat that we have from looking at this on GitHub, which is rather alarming, is that after a developer has been notified of a critical vulnerability in one of their dependencies, 30 days later, only 30% of developers have upgraded their dependencies on average. So upgrade rates are super low. And then the vulnerabilities can recur. You could make the same mistake in your code that your dependency made, and you'd never be the wiser. Or another one of your dependencies could do the same thing. So this is the set of challenges that are affecting, when you look holistically across this workflow and the personas, there's sort of challenges at every step. Now, the good news is, at GitHub over the last 6 months, we've been investing heavily in every part of this workflow. And we're going to show you some of the progress we've made, and we're going to make some new announcements today that I think you'll be pretty excited about. So to take you through that, please welcome my colleague, Gray Baker. Gray?
I'm going to talk you through the work that GitHub has been doing to secure that open source workflow. I'm going to start from the very beginning, where, as a security researcher, you found a vulnerability, to the point where you pass that on to the maintainers and the work they do, and finally to the end user upgrading to a fixed version and diffusing that vulnerability in their code base. So let's start at the very beginning. Imagine I'm a security researcher, and I think I've found a vulnerability in Webpack. The first thing I probably do is go to the Webpack repo and find a way to contact them. So as a security researcher, I probably know to look in this repo for any information around security. And I quickly find Webpack's security policy. That security policy tells me how to disclose that vulnerability in private. But if I wasn't a security researcher, maybe I wouldn't have known to come straight here. GitHub has a special handling of security policies. If you have a security.md file at the top level or in a .github folder on your repo, then when I go to create an issue on your repo, you'll see I'm immediately directed to that policy if my issue's got anything to do with security. So by having that policy, the Webpack team are helping avoid uncoordinated, accidental public disclosure, and they're helping protect the the millions of users of Webpack, if you're an open source maintainer, I really recommend having a security policy in your repo. Now let's suppose the Webpack team agree that I have found a vulnerability. They need a place to collaborate on fixing that vulnerability in private, and then when they have fixed it, they need an easy way to tell the world about it. They can do that using security advisories. Now, I can't demo this part on the Webpack repo because I'm not a maintainer of Webpack, so I'm going to demo it on a repository that I do have maintainer privileges on. There's a security tab on every repo on GitHub, and if you click into it, you'll find details of any alerts, which I'll talk about later, but also the opportunity to create advisories about that repo. Here's one that one of my colleagues has created, and it's in draft form. That advisory is a private space for me to work with my fellow maintainers and anybody else I invite in as we figure out how to fix a security vulnerability. We can write comments to each other, and those comments are private. And we can also collaborate on code together in a private fork. Then when we're ready, we can merge the contents of that private fork into our upstream repo. And it's only then that the work that we've done will be visible to the wider community. Finally, when we have that fix, we want to publish it and tell the world about it. Security advisories have a way to do that as well. When we're ready, we can fill in details of the vulnerability. So you're going to get rich metadata that's going to get published to the community so they can better respond to this. And we can click to publish the advisory. When we do that, we're creating a record on our repository, but we're also alerting GitHub that there's a vulnerability in this particular dependency. And what GitHub will do is add it to a database, which is publicly available, completely unencumbered, accessible via an API, so that the community can respond to that vulnerability. It's the perfect way to have a coordinated disclosure. And today we've got an announcement about how we're improving this process, because you might have seen when I was entering details that I had the option to enter a CVE, which is a unique identifier for a vulnerability. I'm excited to announce that GitHub is becoming a CVE numbering authority, which means that you'll be able to apply for a CVE from within GitHub, rather than having to go through a flow externally. It means that GitHub will be the easiest way to disclose a vulnerability in a best practice way, and that data will then be available to the whole community. It's really cool. It's really cool. And I want to thank the team at MITRE for being so easy to work with on this process. They've made the process of becoming a CNA for GitHub a real pleasure, so thanks, MITRE. So now, once that alert has been published, the final step is for end-user developers to upgrade to a fixed version. This is where GitHub security alert emails and our automated security fix pull requests come in, and I want to demo them now. And I've got another announcement, which is previously we supported Java, .NET, JavaScript, Python, and Ruby for those. Today, well, over the next couple of weeks, we're rolling out support for PHP. So I'm going to do this demo using PHP. So I've got a PHP repo here, and I want to introduce a dependency, and that dependency is going to have a vulnerability in it. The dependency I'm introducing is CommonMark, which is a markdown rendering library. And it turns out that in 0.18.2, there was a high severity vulnerability that's now been fixed, and the maintainers of CommonMark created a GitHub security advisory for that. So let's see what happens when I push a vulnerable dependency to GitHub. Here's the repository. You can see that that push has just been received. And in a couple of seconds, GitHub has identified that I now have a vulnerable dependency in my repo. I can click through to see details of that vulnerability. And in the background, GitHub is creating an automated security fix pull request. Now, that's going to take a minute or so, so I'm going to talk to you a little bit more about how GitHub does this. So on the one hand, we have all the advisory information that's been published by the Common Mark team. As I said, that happened to be a GitHub security advisory, but GitHub also listens to the NVD looking for any vulnerabilities that have a CVE that weren't published in that way. Then we combine that with GitHub's dependency graph, which is our scan of every repository's dependencies, so that we can find vulnerable dependencies for you. Now, that pull request is just taking a moment to generate, so I'm going to show you a version that I already have set up earlier, which is here. GitHub has generated a pull request that updates the minimal amount in order to fix this security vulnerability. It's just taking me up a patch version. I can see that my tests are passing. I can view the changelog and release notes, which both have details of the fix, and I can merge with confidence. And when I do so, my repository is going to be fixed. The final thing I want to talk to you about is the work that GitHub has done for security teams. So now imagine that this vulnerability doesn't affect just one of my repositories, it affects hundreds. Firstly, previously, GitHub would have sent around 100 emails to you, one for each repository that was affected. We're sorry about that, and we're improving those emails, so you'll now get one email that rolls up details of that vulnerability for all of your affected repositories. The second thing that's available now is if you are a GitHub Enterprise customer, you'll be able to see details of the vulnerabilities in your Dependency Insight screen. So if I go to my organization and I click on Insights and then Dependencies, I can see details of all of the dependencies I'm using within my organization. And I can click into the ones that have a security vulnerability. Here we'll show just the critical security vulnerabilities that are open. And clicking into details of any of these will tell me which repositories I have that are affected. So as a security team, you can easily prioritize which repos you're fixing first. So you've seen the flow from end to end to diffuse a vulnerability in an open source dependency. I've got one more thing I want to show you before I hand back to Nat, which is around token scanning. So the work that GitHub's done in open source dependency security is great, but there are other kinds of security vulnerabilities as well. And one that we already help with is credential scanning. It's the easiest thing in the world to accidentally check in a credential. And if you do that on an open source repository, that's a problem. You've just given the keys potentially to your AWS account to the whole of the internet. This is how you wake up with a $50,000 AWS bill and somebody mining Bitcoin on your dime. So every push to an open source repo is now scanned by GitHub to identify tokens like that. And it will automatically communicate with the provider that we found a token that's now in the public domain, and they'll act accordingly. In some cases, that means invalidating the token. In some cases, that means just alerting you. And we have a long list of providers that's growing all the time that we work with in this way to try and help keep your credentials safe, as well as your dependencies. Thanks very much. I'll hand back to Nat.
All right. Thank you, Gray. So as you can see, we're taking this end-to-end perspective on security that runs all the way from the researcher who finds the vulnerability through the maintainer down to the developer, and even includes insights for the security team at your company to understand vulnerabilities not just in one repo or one project, but to get that holistic view over your entire company. We've made a lot of progress, and what Gray's just shown you improves a lot of the problems that we talked about a few minutes ago. But there's still two areas where more work is needed, where there's still major challenges in the security industry that we think at GitHub we have a role to help out with. And the first is that problem of manual vulnerability discovery. The fact that we have to rely, the whole of human civilization relies on, some small number of thousands of security researchers finding the bugs before the malicious actors do. And then there's that problem of vulnerabilities recurring, that the same type of vulnerability, the same code pattern, that variants of a given vulnerability might show up in different code bases, different dependencies, or in your own code that you're writing in your team. And so at GitHub, we're in this very lucky position to work with the entire ecosystem of vendors and developers who are working to address these problems. And we've gotten to know a bunch of the companies in this space. And one company in particular has an absolutely groundbreaking technology that has had a huge impact on the ability of security researchers to scale their work, and then developers generally to apply their knowledge to their code base at scale. And so today, I am very excited to announce that GitHub is acquiring Semmle. This is a big deal. We really could not be more excited about the team and the technology that are joining GitHub and the GitHub family with Semmle. Semmle has the world's most powerful semantic code analysis engine. They can take code and turn it into a graph that we can query and learn from. And we're bringing together the world's most powerful semantic code analysis engine with the world's largest developer community, and the potential of that is absolutely enormous. So to tell you more, please welcome Semmle's CEO and co-founder, Oge de Moor. Oge?
Thanks very much, Nat. I could not be more delighted to be here, and I could not be more excited about the future of securing all the world's code together. Semmle's technology is based on the idea of code as data. It takes the code in a repository and it turns it into a graph that you can search and analyze with simple, concise queries. The queries are simple and concise, but they actually do deep semantic code analysis. And in particular, if you know about a vulnerability that was caused by a coding mistake, you can go and look in your own repository and other people's repositories for other variants of that mistake. And so make sure that a whole class of vulnerabilities is eradicated once and forever. You can also use the technology to make sure that such vulnerabilities, such mistakes, never enter production in the first place. When a security researcher writes a query, diagnoses the vulnerability, writes a query to find instances of the mistake, you can run those queries as part of your regular testing process. In particular, you can run them as part of your code review to make sure that the problem, once identified, never comes back. Once identified, never comes back again. The query language that makes all of this possible is both declarative and object-oriented. And that means that it becomes extremely easy, much easier than before, to create these deep semantic analyses. And indeed, our customers frequently tell us that with Semmle, they're able to identify vulnerabilities that escaped all other means of detection. They also tell us that tasks that used to take weeks or even months can now be accomplished in hours. So I'd like to hand over back to Gray, who's going to show you a demo of how all this works in practice. Gray.
Thanks, Ugo. I am so excited about this technology and what we can do with it at GitHub. It is just amazing, and I'm going to try and communicate some of that by showing you an example of this, but the possibilities are kind of limitless. So I want to talk to you about a vulnerability that I have accidentally introduced in my code. It is a Java deserialization bug, and these happen all the time, and they're really hard to detect, but Semmle just absolutely nails them. So here's my code. I've got a deserializer for octocats, which takes some data and turns it into an octocat. And I've just added a pull request that allows me to accept user input. And it's going to put take that user input, and it's going to pass it all of the way to that deserializer, and that is a massive problem. Because in JavaScript, when you deserialize untrusted payloads, you're essentially giving the person that produced that payload remote code execution on your machine. This is so serious. It is on the OWASP top 10 list of security risks. It has been responsible for so many of the major data breaches that we have seen over the last 5 years. Let's see how Semmle handles it. So fortunately, I've put this in a pull request, and it's got Semmle running on it. And Semmle has found an alert, which is deserialization of user-controlled data, and I can view details of that. So I want to see how Semmle's found this, because it's split across 2 files. There's nothing that you could do in terms of linting that would find it. That analysis has to be way more sophisticated. What Semmle has done is it's followed the code all the way through. It's found the place where I'm accepting user input, and then it's looked to see where that's going, and it's passed through a function, and eventually is being deserialized, and that's where the problem lies. So I can see, immediately that this is genuinely a problem, and Semmle then links out to docs about what I can do about it and everything else. And if you think, oh, Gray, that's just toy code, it's a very simple example, then look at this one, where the paths that I'm flowing through are 12 steps. This is a vulnerability that was announced last week in Apache OFBiz, which is a framework that powers a suite of Apache applications. It was issued a CVE. It has now been patched. And it was found by Semmle, because it's very, very tricky to spot these as an individual engineer. This software allows you to do it automatically. I'm so excited about what we can do with this at GitHub. I'm going to hand back to Nat to tell you a little bit more.
Thank you, Uge. Thank you, Greg. Congratulations to the Semmle team on what you've built. We're so excited to work with you. We're really excited to integrate Semmle directly into GitHub and make these powerful capabilities available to open source developers everywhere and to all of GitHub's customers. And so this is something that we're looking forward to doing over the coming months that I think will have a huge impact. So we made a few announcements today. We've taken you through kind of our strategy. There's a lot more work for us to do, but you can see where we're going and how seriously we're taking this. Today we announced PHP support in our dependency graph, and therefore for security alerts. We've told you that GitHub is now a CNA, a CVE numbering authority, which means you don't have to go to the DMV to tell people about your security problems. You can just do it on GitHub, super helpful for maintainers. And of course, the acquisition of Semmle, which we think is going to bring together this incredibly powerful technology with developers and security researchers around the world. So this is the beginning. I think the key message that I want everyone to take away is GitHub's commitment to really following through on our responsibility and the opportunity we have to secure software development from end to end. But this is also a joint activity. This is something that we're all going to have to explore and going to go on this journey together. Maintainers around the world are going to have to adopt these capabilities, and security researchers are going to have to scale their work, and we're all going to have to take this more seriously over time. So we're excited about that journey. If you want to learn more about what GitHub's doing, we have a page that has a nice summary of our work. You can go to github.com/features/security. We'll have a number of new security-related announcements coming up in the future. And then, of course, in less than 2 months, in I think 56 days, not that I'm counting, we have our major developer conference of the year, which is GitHub Universe. It's here in San Francisco, November 13th and 14th. We bring together hundreds of the world's top maintainers, largest companies that are using open source and using GitHub, developers and students from around the world, thousands of folks. It's a great event, and we'll have some really big product announcements there as well. So hope to see you there. All right, so to everyone who joined us here in the room, and for those of you who joined us online, thank you for spending part of your Wednesday with us. We appreciate it. We're looking forward to your feedback. If you're here in person, we've got some luminaries from the Semmle team who are here, and lots of folks from the GitHub security team. We'd love to talk to you and hear from you online as well. So thank you very much.